Hi students, today we will discuss about few problems based on the dual nature and matter. See the first problem on the screen. When a certain metal surface is elevated with the frequency is given as u, the stopping potential is V naught, and the same surface is eliminated with the frequency u by 2, and the stopping potential is V naught by 4. And the threshold frequency of the photo emission they ask. What is the threshold frequency they ask? So we can use the formula here to find out the stopping potential and all. See, so first time frequency they given as mu, second time is mu by 2, and here stopping potential V naught, and this is V naught. Stopping potential is given means indirectly they given as kinetic energy. And we have the formula K max equals to HU minus work function. HU minus work function. So this you can written as K max value EV naught. Okay. Now here, first we have to write two equations initially. The given as stopping potential is V naught is equals to HU minus 5. This is the first equation. And the second time the given as stopping potential is V naught by 4. Then EV naught by 4 equals to the frequency also becomes half HO by 2 minus 5. This is second equation. Okay. Now, if you solve the equation 1 and equation 4, see, from the first equation, we know EV naught value. So, from 1 and 2. So, this we can replace 1 by 4 times of EV naught. EV naught value we have HU minus 5 equals to HU minus 2 by 5. Now, if you do the cross multiplication, we have H nu minus 5 is equals to 2 H nu minus 4 time. Okay. Now, to solve these two equations, you have 5. If you can exchange this side, it becomes 3 pi is equals to H nu. 3 pi is equals to H nu. Okay. Now, the threshold frequency we can write, suppose phi is equals to H mu by 3 is there. They ask what is the threshold frequency. So work function we can replace H mu, So work function is equals to H mu by 3, that is equals to, this is H mu naught. H get cancelled, so threshold frequency is mu by 3. This is. So option 4 is the correct answer. So we can take the two equations and substitute that from equation 1 and 2. Okay. So I hope you understood. See the next problem here. What will be the ratio of the de Broglie wavelength of the proton and alpha particle? They ask here de Broglie wavelength of proton and alpha particle. And we have the de Broglie wavelength formula lambda equals to h by b. And condition they given same kinetic energy. This is important. So normally most of the students can commit the mistake by taking mass and all. So whenever they given kinetic energy, we can use this formula 2mk. 2mk. Here h is Planck's constant. It is a constant. And the mentioned here kinetic energy is same in both the cases. So we can write proton by alpha particle means lambda is inversely proportional to the mass. Lambda is proportional to the mass. So we can write lambda mass of alpha by mass of the proton. And alpha particle we know it is 2He4. So mass is 4 units, charge is 2 units. So lambda proton by lambda alpha equals to mass of the alpha particle is 4 times. When proton mass is m, then it becomes 2:1. So answer is 2:1. So whenever the given kinetic energy is constant, we have to focus on this particular formula. Okay. Next. Third one, see. Here, the light of wavelength 4000 angstroms falls on a sensitive plate with a photoelectric work function they given 1.90 electron. The maximum kinetic energy of the emitted photoelectron will be given. So it is a very easy problem. First, by using this, how much energy it is eliminated means energy formula, we have the shortcut for 12,400 electron volt by lambda is 4,000. So these two get cancelled. So it is becomes so this is 124 or otherwise 12.45. 4 is there. So it becomes 3.1, nearly become 3.1 electron volts. And we have the formula energy is equals to work function plus Ke maximum. Now here they ask Ke maximum. So K max equals to, we can write work function energy minus work function. Energy we have nearly 3.1 electron volt minus work function they given as 1.90 electron volt. So if we take the difference of these two, so this is equals to 1.2 electron volt. So answer is option 3 is the correct answer. Okay? Yeah. So next one you see, next problem. Option 2. Choose a correct graph, the intensity of incident light and photon current. We know intensity intensity is directly proportional to photon current. So we shall use this. Okay? Option 2 is the correct answer. Now see the fifth one. Fifth one. The number of photoelectrons emitted per second from a metal surface increases when the number of photoelectrons emitted per second, this number of electrons emitted per second is depends upon which physical quantity they are asked. So intensity of incident light increases, keeping the frequency constant. So option 4 is the correct answer. Okay? If you make it as frequency is constant, the intensity of incident light is keep on increasing. Keeping the frequency is remains constant. Can you write? Number of photoelectrons is directly proportional to the intensity. Right. Okay. Next, see the problem number 6. A particle M is at rest So initial velocity is equals to just. In rest means initial velocity is 0. Decays into the two particles M1 and M2. Now what they ask here, the ratio of the de Broglie having non-zero velocities. Non-zero velocity means they have some velocities, and what about this? They ask. So it is like collisions concept if you take. This is the collision. We have the mass M. So initially it is in the state of rest. So it is dissolved into the two fragments. Means this is M1 and this is M2. And we know that any types of collision, either it is elastic collision or inelastic collision, momentum is conserved. Momentum is conserved. Means M1, this is V1, this is V2 means. Initial momentum should be equals to final momentum. This is initial momentum. This is the final momentum of the system. So initial momentum is 0. Final momentum we can write M1 V1 plus M2 V2. Now here, so we can write the magnitude of M1 V1 is equals to magnitude of M2 V2. Means whenever a mass is dissolved into the number of fragments which is in the state of rest. After the dissolving into the number of fragments, the momentum is always conserved. So we can write here lambda is equals to what the formula we have h by p. This is nothing but p now. So 1 is to 1 is the correct answer. Why? Because here P1 is equals to P2. And you have H is a constant we have. So momentum is conserved here. Okay. So if you want, momentum is conserved here. Okay. So initial momentum should be equals to final momentum. So using law of conservation of linear momentum. Okay. Right. Now the seventh one you see. In a photosensitive effect, photoelectric effect experiment, we have the graph between the starting potential and frequency of the three metals of work function X, Y, Z given below. Then the metal of minimum work function is the R square. Okay. Now see, for example, this is a graphic they give. So this is given as, suppose we are extending intersection Z. This is Y. And this is X. Now here they ask, it will give work function Z by T. So why? Because this is the graph between V naught and this stopping potential and the frequency they given. Yeah? This stopping potential. This is for the second one. By Y by P. This is by Z by P. Now we can write here which is correct one. Means here which is having more slope here. The metal of minimum work function is for the Z by X here. This is sorry, this is okay. So this is having less slope we have, which having more slope. Okay. Next. Next is 8th problem. And the given here initial velocity is v is equals to v naught. It's projected into the electric field. It is an electron. Okay? And it is E naught. Okay? Now they ask here, what is de Broglie wavelength? Suppose initial de Broglie wavelength, if we take lambda is equals to h by 1v. In other words, lambda not equal to. Now, as we know that acceleration of electron is A is equals to E cube by N. Or according to the problem, we can write T naught into E by M into time t seconds. Time t seconds. Now velocity after t seconds. Velocity after t seconds means we can write V equals to V naught plus E naught E by M into T. Now I want de Broglie wavelength for this. So de Broglie wavelength lambda is equals to h by mv. So we can write lambda is equals to h by m v naught, m common v naught plus e naught e by m into t, we can write. Okay. So for the space constraint, I will write here. So lambda equals to h by, in denominator v naught if you take common. So v naught if you take common, so this is m v naught to 1 plus e naught e by m v naught into t. See, this term is nothing but lambda naught. So lambda is equals to lambda naught by 1 plus e by m v naught into t. Okay. So what is the correct option here? Option 1 is the correct answer, C. So here this is the concept we have to link to the motion in a straight line chapter. Motion in a straight line chapter, if we take straight line and electric charges and fields, motion of a charged particle in a uniform electric field, where we can use this formed acceleration of the charged particle. Okay. Next, 9th one. See, a 4 centimeter thick surface eliminated the weight of lambda. The stopping potential is V. Same surface eliminated with 2, and this is V by V. Same surface means the keyword here, work function is same. Work function is same in both the cases. So then what is the threshold wavelength they ask here? So simple, work function is same, so we can ignore that here. So first equation is EV is equals to HC comma 1 by lambda minus threshold wavelength lambda naught is the first equation. Second equation, stopping potential becomes 1 by 4. That equals to HC into 1 by 2 lambda minus lambda naught. That's the first equation, and this is the second equation. Now, if you take the ratio of these two equations, equation 1 by equation 2 if we take, so it becomes 4. Few terms get cancelled. 1 by lambda minus 1 by lambda naught by 1 by 2 lambda minus lambda naught. After do the cross multiplication, get 4 into 1 by 2 lambda minus 1 by lambda naught. We can take this lambda naught if we take equals to 1 by lambda minus 1 by lambda naught. Now it becomes 2 by lambda minus 2 by lambda naught equals to 1 by lambda minus 1 by lambda naught. So take lambda naughts one side, the rest of the terms at this side. The artificial wavelength. Then we get lambda naught is equals to 3 lambda. Okay. Option 2 is the correct answer. Next, 10th one is number of photons emitted of wavelength 5400. This 5400 we can recognize, and a bulb of 100 watt is there. So suppose wavelength we can write here 5400. I will write 5400 angstroms. 5400. So generally power formula we have NE by T. So they ask the number of photons emitted. So N by T they ask. So we can write power by energy. So energy formula we have. We can use two different formulas. 12,400 by lambda 5,400. We can do it. You will get the energy in terms of electron volt. RLs in general method we have B is equals to Hc by lambda, also we can do it. Okay. Now we can use Hc by lambda, suppose P by Hc by lambda. In both the cases, we will get the same answer here. See here, power they given as 100, you write as it is. Lambda they given as 5,400 angstroms, means 10 power minus 10 meter, by Planck constant value instead of the I will write 20 by 3 into 10 power minus 34. Okay. And C value 3 into 10 power 8. So this 3 will get cancelled. Okay. 3 will get cancelled. And what is the answer we get here? P100. So here the given energy is they ask per second means when they ask. Okay. How much will that get? So you will get 3 into 10 power 20 from the answer. So a small modification here. So whatever the values they given, that we can take, then you will get exact answer. Otherwise you have some confusion. So here, P how much they given? Suppose N we want. This is 100. Lambda is 5,400 angstroms means 10 power minus 10. This is 6 into 10 power minus 34. And C value we given as we know 3 into 10 power 8. So now you will get the 18, 6 threes are 18, 18 threes are 54. Now you get the exact answer, 3 into 10 power 20. Okay. Actually, the given as another one. Okay. Right. Next 11th. In a photoelectric effect, if the intensity of the light is doubled, then the maximum kinetic energy of the photoelectrons will become. So no change. Kinetic energy is independent of intensity of light. So no change here. Okay, next. The stopping potential in a photoelectric effect is 1.6. Then the maximum kinetic energy they asked. Stopping potential is 1.6 volt, the maximum kinetic energy they asked. So very good. This is, we have the formula K max equals to EV naught. So maximum kinetic energy equals to stopping potential 1.6 and 1.6 into 10 power minus 19. 16, 16s are 256. This is minus 19. Sure. So option 2 is the correct answer. Okay. Next one. 36, you see, a charged particle having a charge Q and mass M projected along the y-axis with velocity v naught. So initial velocity will be given as v naught. If a uniform electric field is along the x-axis, then the time at which the de Broglie wave of the particle becomes 1/3 of its initial value. 1/3 of its initial value. Okay, see. So we should write here acceleration. Why? Because here it is a charged particle, means it is a positive charge. They're not mentioned it is a negative charge. So electric field is along the x-axis, means acceleration we can write E Q by M into T. It is along the x-axis only. Okay? So velocity along the x-axis Vx. We can write dq by t. Okay? As a function of time, we are asking Vx is equals to aq by m into t. Why? Because they are projected along the y-axis with v naught. Along the x-axis, initial velocity is 0, no? So we can take it as 0. Now, here the given, the de Broglie wavelength of the particle 1/3 means h by 3 m v naught. Initial de Broglie wavelength, if you take lambda is equals to h by m v naught. So it becomes 1/3. That is equals to, we can write. And we have an acceleration along the x-axis and y-axis also. This is x-axis. What about the y-axis? Along the y-axis, velocity is equals to E cube into T. E cube into T. Okay? So we can write m v naught. H by m is equals to, we have the formula. Initially, momentum and v naught square plus EQ into T square. T square. Now that get cancelled, do the cross multiplication and squaring on both sides. It becomes 9m square v naught square is equals to m v naught square plus e square q square t square. Yeah, this m naught will come, this side becomes 8m square v naught square equals to e square q square t square. Okay, so we want t square equals to 8m square v naught square by e square q square. So we want to tan root 8. Root 8 means becomes 2 root 2 m naught v naught by e cube. Yeah. So the next one, see here. The work function is radiation 6.2 electron volt of a metal flux. The kinetic energy of the fastest electron is 3.6, 3.2 into 10 power minus 19 joule. Then the work function they ask. So we have the formula, energy is equals to work function plus kinetic energy. So work function, and they ask here the work function. So work function is equals to E minus P. T minus P. So pi is equals to so work function is 6.2 electron volts. And here energy they given as 3.2. That also we should convert into the electron volts. It means 3.2 into 10 power minus 19 by 1.6 into 10 power minus 19 becomes 2 electron volt. This is okay. So we have 6.2 electron volt minus 2 electron volt. Then it becomes 4.2 electron volts. So here the problem is very easy. The only thing, this we should know how to convert this value into the joules. Okay? Joules from electron volts. Next. The maximum kinetic energy emitted of the photoelectric effect always depends upon only frequency. It purely depends upon the frequency. Next. The maximum kinetic energy of the photoelectron is E, and the wavelength is lambda. Then it becomes, the energy becomes 4 times. When the wavelength reduces to 1/3. Then the work function they ask. What is the work function they ask? So we should find out the work function here. As usual, this E is equals to, we have the formula. Energy hc by lambda minus work function. This is So first time energy is maximum can this is maximum kinetic energy. Suppose if you want K, you can write K is equals to h by lambda minus work function. First time is K. Second time it becomes 4 times. So we can write 4 K then hc by wavelength is reduced to 1/3 means lambda by 3 minus work function. So this is equation number 1. This is equation number 2. Okay. Now if you solve these two equations, we can get the answer here. Why? Because from the equation 1, equation 2, 4, Ke value how much? Hc by lambda minus 5 equals to 3 hc by lambda minus 5. This is 4 hc by lambda minus 4 pi is equals to 3 hc by lambda minus 5. Okay, so that we can exchange the terms here. This is hc by lambda equals to 3 pi, then pi is equals to hc by 3 lambda. hc by 3 lambda. So option, which is the correct option here? hc by 3 lambda means option 4 is the correct answer. Okay, next. De Broglie wavelength of de Broglie wavelength of alpha particle with mass m and kinetic energy 2 kg. So this is one of the easiest problem. We have the formula lambda is equals to, in terms of kinetic energy, 2mk. So lambda is equals to h by 2. M you write as is kinetic energy is given as 2k. So it becomes h by 2 times of root. Yeah, okay. So option 2 is the correct answer. That's 41. So which is having the mode means platinum. So its work function is 5.65 electron volt. Cesium is less. Now, so this is a little bit typical problem. So they ask radius, they ask. So we have the formula radius r is equals to mv by bq. And this is root 2m k by bq. So bq means be. So option either this or this. And we know that energy is equals to, so energy is equals to hc by lambda, or otherwise we can write work function plus kinetic energy, Ke max. So I want Ke max equals to E minus 5. Then R is equals to, what's the formula? 2mk E minus 5 by PQ or EB. So option we want, this is root is there, we want outside the root. So option 4 is the correct answer. Right? Next, C. So the one, this is the one of the typical problem. So they ask here from the graph which is having a proper they ask what is a Planck constant value. So most of the students have the doubt, sir, Planck constant is constant. Now why should we should find out? See, here the rate, the slope of this graphs, the slope of this graph will give h by e. Okay? So slope is equals to H by T. This is for the metal A, we can write now. Metal A. This is H by T equals to slope of the first metal, this metal. If you take 2 minus 0, y2 minus y1, 2 minus 0 by x2 minus x1 if we take 2 minus 0 by, so 10 minus 5, see, from here to get this is how much? 10 minus 5 into 10 power 14. Now I want H. H is equals to 2 into 1.6 into 10 power minus 19 by, this is 5 into 10 power 15. Okay. If you do the calculation part, you will get 6.4 into 10 power minus 13.4 joule second. So first part is this. The second part for metal B also if we did H by E, slope is equals to what we have here, 2.5. So this is 2.5 if you take 2.5 by 2.5 here. If you take this is 15 minus 10, how much it is? 5 into 10 power 14. So H is equals to, this is becomes 1 by 2 into 1.6 into 10 power minus 19 by 10 power 14. This is 0.8. So this is equals to 8 into 10 power minus 34 joule second. So this is the correct answer. Okay, that's all for today. Thank you very much. We will meet in the next video. Most probably it will publish in the afternoon session with PYQs. Thank you.